Hey folks. Okay, this time around I want to walk through an overview of lab exercise 3, and then I want to work through kind of the beginning steps for solving this. And I think what I'll do then is work through a complete example of designing and going through the incremental implementation and testing of a full version of a similar program. So we'll try and get kind of as close as we can to the same idea without actually giving you the solution to Lab 3. So that's kind of the plan. And again, I'd recommend going through this and just following through as far as you need to be able to work through and develop your own solution for the lab. So for this one, we're again practicing with functions, but now we're introducing pass by reference parameters. So cases where we can pass a variable to the function and have the function actually fill in the value. We'll be getting one recursive function, so one function that's going to, in this case, prompt the user over and over and over again to try and enter some values and keep going until they give valid values. And we'll use a recursive approach to that, right, where the function calls itself if needed. And then we'll do one more function that uses a loop to get repetition. And so again, it's going to be getting some kind of different value from the user and prompting them over and over and over until they give a valid value, but we'll be using a loop inside that function rather than recursion. So that's the idea. Again, in terms of getting fired up for the lab, obviously hit the page, read through the description, and again, as usual, we've got a syntax examples page that just goes through and talks a little bit about pass by reference if you need a refresher, talks a little bit about recursion if you need a refresher, and gives some examples of while loops, do while loops, and for loops for this one. So refer back to those if you needed. And again, I'm assuming that you're kind of up to speed on things prior to Lab 3. So for this one, we're going to be needing ifs and elses and else ifs and whatnot. We'll be needing pass by reference, we'll be using loops, we'll be using recursion. Obviously you have to keep up with the code standards for the lab, and again, hopefully I've given you reasonable feedback on your previous lab so you can see what went on there, any places where I had kind of higher expectations for the standards. And what we want this program to do is it's going to let the user to pick a shape, either a triangle or a rectangle, and it's going to go through and compute the area of that shape. So they're going to give the height and the width of the rectangle or the triangle, and it's going to go off and compute and display the area for them. And we'll be using a few different functions to do that, and each of them will be called from the main routine. So we want them to get them to pick a shape, rectangle or triangle, enter the height, enter the width, compute and display the area. And a couple of simplifications there just to make our formulas nice and straightforward. Let's see, in terms of picking a shape, we'll get them to enter a character for that, either a T or an R to indicate triangle or rectangle. And they can enter it as upper or lowercase. So what we'll do is try and read in the character and convert it to uppercase, and then we just have to see if it's an uppercase T or an uppercase R, and then we have a valid shape. So we're going to have one function that's going to get called from the main routine to get them to pick the shape, and if they enter a T or an R, then we'll return that value. If they enter anything else, then we want to get them to try again. So this is one of those examples where select shape is going to use a recursive approach. And so we'll prompt the user to enter a T or an R. We'll read it in, maybe try and convert it to uppercase, and that's using that to upper function. So convert it to uppercase, and then if it's a T or an R, then we'll simply accept it and return it. If it's anything else, then we'll say, no, that wasn't a valid selection, please try again, and we'll call the function recursively to get it to try again. So we'll have this select shape function that we've got to write. We'll have another function that's going to get the height and width of the shape, and so we're going to use pass by reference parameters for this one. So we're going to pass two variables to the function and get the function to fill in the values there. So it's going to take two pass by reference parameters, one for height, one for width. We're going to use doubles for the sizes in this, and it's going to have void as a return type. All right, it's not going to return a value, it's going to put the values in the two pass by reference parameters. And so for this one, we'll use a loop to go through, and what we'll do is prompt the user to enter the two values, we'll read them and error check them, and if either of them is wrong, we'll get them to try again and enter both values again. So this time we'll be attempting to use, let's say our cin for instance, to read in the two values and then go through and check if cin failed for either of them, or check if either of them was a negative number, for instance, which obviously isn't valid for a height or a width. And so we'll go through, do error checking, and we'll use a loop. And you can use whatever kind of loop you like, whether it's a while loop or a for loop or a do while loop, to go through and keep repeating until eventually they give you two valid values. Finally, we'll have our display area routine that takes the type of shape, so a single character that's going to be either an R or a T, the height and the width that they chose for the shape, and it's going to do the computation, it's going to compute the area and then display it and say, okay, well, for your triangle of size, whatever by whatever, the area is whatever. So in terms of the computation, again, for the rectangle it's just width times height, and for the triangle it's just that divided by 2. So we can compute the area and display it, and our main routine just has to create the 3 variables that we'll use for this. So a variable for the shape type, a character variable for the shape type, and then a couple of doubles for the height and width. It'll call select shape, get that value back. It'll call get dimensions and pass the 2 variables that we want to store the height and width in. And then it'll call display area and pass the shape and the height and the width. So the main routine is going to be, just a couple of 3 variable declarations and then 3 function calls pretty much. So this should be nice and straightforward, and most of the work is done in our 3 functions. So as always, what I'm going to suggest is you take a very incremental approach to building this out. So we'll look at getting started here. We'll go through the process of getting our lab in the first place, doing kind of a first pass through to get the vague structure, and then look at what kind of a sequence I would go through to actually build out all the rest of it piece by piece, and just a couple of suggestions along the way. And then we'll look at a similar example just to go all the way through and show you the whole design process for a similar problem, but not actually this problem. So there's the plan. So what we'll do is start off by, let's say, getting our lab here. So again, it's pretty much just in your home directory. So, do a cd or check that you're actually in your home directory, and then do your make-f, make 160, and the lab we want to create. So let's say csci.160/labx3. Oops, and I've already got a csci.160/labx3. Let me get rid of that for a moment. You won't need to do this most likely. csci.160/labx3 to temp. csci.160/labx3 old. Sorry about that. So you're going to go through that same make process, and it's going to go off and try and grab your labx3 and bring it over. So you'll see it's contacting the server, getting the files, creating your labx3 directory, and now we should be able to go into our csci.160 and into our labx3. And when we get there, we'll see we've got our labx3.cpp file, the make file, and a readme. And so I'm just going to dive into our .cpp file there. And again, it's going to start off as pretty much a blank file. And so what we want are the 3 functions that are described in the lab. Of course, we'll need our libraries and whatnot. So I'm just going to get this started and say, okay, well, let's stick my name in here. And a description, program to get shape type, triangle or rectangle, and dimensions, height, if I can spell, height and width from user, then compute and display the area. And again, for the most part, I'm going to try and write some kind of a description right from the very beginning, just so I've always got this record of what I was attempting to do here. Now, we're going to need to perform some I/O, so I'll use the old IO stream library, and again, for now, we'll just use our standard namespace. And we'll have a main routine that does some stuff. And for a moment, I'm just going to try this out just to make sure that things can compile and submit. So let's give this a try. Let's do a make to get it to compile. Okay, seems to compile okay. Let's try a make submit. And again, you can submit as often as you like. It's just kind of updating the stuff on the server side with your latest version of the program. So I'm just going to do this to see if I can actually submit okay. Yeah, looks like it submitted okay. It's basically pushing all this stuff back over to the server where I can mark it somewhere. So that looks relatively okay. So now let's go through and try and work on our program a little bit. So the idea was we had these three functions that we wanted to create, right? A function to get the user to select a triangle or a rectangle. And so again, we're going to get them to come up with a character for this. So what did I call this in the specifications for the lab? The specs for the lab say it has to be called select shape. It has to return a char. And it doesn't need to take any parameters. So we've got this one function that we're going to use to select the shape. We're going to have another function for get dimensions, right? Get the user to select the height and width, or to enter to provide, let's say, the height and width of the shape, of a shape. And so again, for this one, the lab specs tell you what the profile is supposed to do. Essentially, it says that the function has a void return type, so we can use that. The function's name is supposed to be get dimensions, so we can use that. And it's supposed to have two pass-by-reference parameters that are both doubles. And so we're going through and saying, okay, well, we want to get the height, and we want to get the width. And so we're just going through and kind of trying to outline what we're going to wind up needing here. So we'll go through and have our functions to get the shape, get the height and width, and then this one more function that's supposed to go off and display the area of the shape, of the selected shape. I guess compute and display. And so again, for this one, it's supposed to have void as a return type. What did we say the name was supposed to be? The name was supposed to be display area. And it was supposed to be taking the three parameters that we want to work with. It's supposed to be taking the kind of shape it is. It's supposed to be taking the height. Oops. And it's supposed to be taking the width. Right, so we can go through, create the prototypes, the shorthand versions of these things up top. And then I'm just going to cut and paste this whole thing down to the bottom so I'm going to get my full implementations match these. Now remember, for the full implementations, you don't have the semicolon at the end there. They actually have the body of the function instead, so I'm just going to do that first. And that select shape is going to have to get the user to enter some kind of a shape as a char and eventually return it. So for this to compile cleanly, I'm going to need to make sure that I actually have a return in there. The other two are voids. They don't return anything, so I can leave empty bodies for these. And that's probably where I would leave it at just kind of a first stab here. Right, we can go through and try and compile that. And so all the warnings I'm getting here, you'll notice, are for unused parameters. So I'm doing things with, or I'm declaring parameters for height and width all over the place and for shape, but not actually doing anything with them yet. So that's kind of to be expected at this point, because I am actually going to use those parameters inside the functions as I build out the functions. And I guess the other one down here is that in that select shape that I wrote, I'm returning a value of s, but I'm not actually putting any value into s yet, which of course I'm going to fix as soon as I prompt the user and say, please enter a shape, and I'll try and read something in. So those are all pretty much to be expected at this point. Any other errors would probably be a good indication of something I needed to fix before I move on. So again, we're just going to go through and take this in kind of an iterative approach. In my main routine, right, I'm going to want to go through and declare variables for the shape type, the height, and the width. And of course, the shape type I'm going to want is a char, the height and the width I'm going to want as doubles. I'm going to want to call select shape and store the return value in my shape type variable. I'm going to want to call the get, what did I call it? Get area? Get dimensions. Call get dimensions, passing the height and width variables. And then finally, I'm going to want to go through and call display area, passing shape type, the height, and the width. And that's pretty much what I'm going to want my main routine to look like. I pretty much, there might be, I guess, 2 lines for my declaring the variables, or 3 lines if you declare them 1 per line. And then these 3 simple calls. And that should pretty much be my main routine. Now, I'm not going to give you any more of the code for the actual Lab 3 exercise, right? You can work from here on your own, start building through this stuff. But what we will do is walk through the entire development process with, let's say, a similar example. So I would really strongly recommend seeing if you can kind of progress on your own from here. But the plan I would suggest is, let's come up with a little plan for my incremental development plan for LabX3. So first step is going to be getting the function prototypes and skeleton implementations. And this is now done. Right, we've got that part done. Then I'm going to go through and write maybe the body of my select shape, but without recursion at this point. We'll just prompt the user once and assume that they actually get it correct that first time through. So no recursion yet, no error checking, right? Just prompt the user to enter a shape. Read it into our character variable, and then return it. And so then I will, of course, compile and test. Right, see if it actually prompts me and fixes it up okay. Then the next step is I'll do something similar for the get dimensions. Right, the body of get dimensions. No loop yet. No error checking. Right, just prompt the user to enter the the height and width, read them into the two parameters, right? And they're passed by reference, so it'll actually go into whatever variables the main routine passed. And again, at that point, I'm going to compile and test. And so it should, at this point when I run the program, it should be telling me, you know, please select your shape, and I'll enter a T or an R, and it'll read that and presumably return it. It'll prompt me to enter my 2 dimensions. I'll type those in and it'll store them. And again, no error checking at this point. And then we'll write the body of, oops, I guess maybe I should stick in the calls from the main routine. That may be a good idea. Call it from the main, passing, or storing the result in the char variable. So, oops, I'll write the body of the function, write the call from main, and just see if it actually works and runs. Same thing for the get dimensions. I'll write the basic version of get dimensions, and then I'll call it from main, you know, passing the 2 doubles. Then we'll write the body of display area. And again, all we'll do is, you know, display the shape type, the dimensions, and compute and display the area. And again, the computation should be pretty straightforward, right? For a triangle, then it's the height times the width over 2. If it's an R, then the area is just the height times the width. Or maybe I just compute the height times the width first, and then if it's triangle, divide by 2. But again, we'll write the body of this thing. We'll call it from main, you know, passing the 3 variables. And again, we'll compile and test. And at this point, if I type in valid data, the program should actually work correctly. So this should go reasonably smoothly, right? We can get an implementation to this point that looks pretty good. And then I'll start going back and working on my error checking and my loops. So maybe my 5th step will be, I don't know whether you want to try the recursion first or the loop version first, but I'll try the recursion first here. So let's get recursion and error checking working in select shape. So for this one, now we want to go through and say, alrighty, what will I need to do for that? So now we'll modify the code before to say, you know, after we've read in the character the user entered, what could we do? We could go through and convert it to uppercase first. So I could say something like, you know, if I had my convert to uppercase, let's say. So let's say I had my shape type in a variable called shape type. Then I could say something like shape type equals to upper shape type. So again, what that's doing is saying, look at what's in the shape type variable right now. So they could have typed in an X, they could have typed in a Q, they could have typed in a lowercase t, they could have typed in an uppercase t, and it's just going off and looking what the uppercase equivalent of that is and storing that here. So if they entered a lowercase t, we've got the upper. If they entered a lowercase r, we've got an upper. If they entered an uppercase already, then it's still just that uppercase. So now we don't have to worry about whether or not they entered lowercase letters. So just makes the user input a little bit simpler and a little simpler to check. So we'll go through and try that first. And then see if what they entered was valid. So I'll go through and essentially say, if the shape type isn't T and it isn't R, display an error message, call the function recursively, right, call select shape recursively, putting the return value into my shape type variable, for instance. So now, right, and I guess then return the shape type. So we're putting this error checking in between the area where we read in what the user typed and the point where we actually return a final value from the function. So hopefully this should actually take care, and of course I'm not actually giving you the code here, but this is the logic that I would follow through to see if we can actually get the values from the user and just keep on going until eventually we get a valid response. So again, at this point I'm going to compile and test. And in terms of testing, I'm going to try entering invalid characters for the shape type and see if it actually prompts me to try again. Right, and I'll just go through and debug that until it works. And then we can go on, and as my last stage, let's get the loop and error checking working in my get dimensions. So now maybe we can say, well, after we've read in, or at least attempted to read in, the dimensions, we'll check if cin failed. If so, if it failed, we'll clear the input buffer, do our cin.clear. So let's say do our cin.clear and ignore. And let the user know to try again. Otherwise, if height or width is negative, again, we'll, I guess we should, if the height or width is negative, we'll give the user an error message and give an error message, let the user know to try again. I guess here we should give an error message as well. All right, so if it couldn't read, we give them an error message and let them know they're going to have to try again. Clear the input buffer. If it managed to read but they gave negative values, we'll just let them know that they have to try again. And then otherwise we're good. So in these two cases, if something went wrong, we want to go through the loop again. So how am I going to do that? I think what I would probably do is use the sort of approach that we used in the last example in the lectures, where we said, okay, well, let's create a Boolean variable. So let's say outside the loop have a Boolean variable, something like data invalid, and our loop will check that. to see if it needs to try again. So what I'm going to do is use a value of true in that if it needs to try again, and false in that if it doesn't. So I'm going to pop up to the top of my loop and like pop up above my loop and set that. And so what we'll do is in here, if anything went wrong, we'll set data invalid to true. And the same thing in this case, right? If they gave me negative values, I'll set data invalid to true. And then my general case, my final else case will be to set data invalid to false. So here we're adding our error checking. We're creating a variable to go through and keep track of whether the data that we just read is okay or not. And now we'll embed this whole thing in a loop. So let's have a do while loop around the prompt the user, attempt to read, height and width, and then do all this error checking and have the loop keep going while data invalid. Right, so now we get our do while loop around this whole thing, and it's going to go through and say, okay, well, inside the loop we'll prompt the user, try and read the stuff in, see if it failed, see if the values were invalid, and we'll set that Boolean variable to true if we need to try again, or to false if it looks like everything's okay. And then once we get out, we can return or actually, once we get out, we can just end the function. And we don't have to return anything. In this case, it's going into the pass by reference parameters. So at this point, right, again, this one's a little bit more involved because we've got a sort of more complicated error checking to perform. But really, we're just wrapping that keep going keep going while the data is invalid around our usual kind of error checking. So again, once I get to the end of this, I'll compile and test, right, using invalid heights and widths. Just to see if this thing is actually working. And at this point, you know, we should actually be done. So for our final step there, we'll just make sure we've followed the code standards. Right, we've got reasonable variable naming. We've used constants, not hard-coded values. We've got prototypes above main. And the function implementations below. We've got, let's see, reasonable commenting. We've got proper indentation. We haven't exceeded any line lengths. And again, the max is 96. So again, just scanning through and making sure that we've kind of stuck more or less to the code standards. So those are probably the biggies to watch at this point. So, make sure we've done make submit. And make sure that from inside our csci 160/labx3, we've done our make submit. And so that's kind of the plan that I would take for going through this. And as you can see, there's a lot of steps. There's a lot of things to do there. So I would follow it through and, you know, start early, get through kind of those, at least those first few steps relatively early, and then you can gradually grind away on the recursive one and gradually grind away on the loop one to go through and get the heights and widths. And hopefully this should go relatively painlessly. Relatively. Always remember that when you're playing with recursion, if your program, or with loops for that matter, if you get infinite recursion or an infinite loop, Control-C will kill the program, and then you can go back to editing and working on it. So that is, again, the kind of incremental process that I would follow through for this. We've already got a fairly lengthy video going here, so maybe what I'll do is post a second one that's got from beginning to end development example in it. So I'll post that as a second example shortly.